Hi guys. In previous concept we learned introduction to vectors and we practiced how to add vectors. So just recall what are vectors and how to represent. Vector is a physical quantity which can show its magnitude and direction of a physical quantity. So a vector can represent with an arrow mark. So this arrow mark represents the length of the arrow mark represents the magnitude of vector, and direction is represents in which direction the vector is moving. It is along east direction or it is along positive x-axis direction. So the direction tells about the motion of the vectors in that particular direction. Now let us learn different types of vectors. First one is known as position vector. Suppose this is a coordinate axis x and y. So this is x and this is y. Suppose I am at here. So to locate my position, so where I am to locate me. So with reference to difference axis, with the help of difference axis, we draw a vector with respect to origin. So the vector shows about the location. Suppose the location of me according to at here. So this is the corresponding coordinate of x and the same the corresponding coordinate of y. So if I know this value, suppose if I take this value as 4 and this is also 4, my location in the xy plane 4, 4. Now to locate me, so we have taken the help of a vector. So this vector name is known as position vector. So position vector which gives the position of object with reference to the origin of the coordinate system. So that is known as position vector. This position vector tells about the distance of the object from the origin. The length of the vector tells about the distance of the object from the origin, and it tells about the direction too also. So what is the direction? So I need to measure the direction with the help of protractor here. Let this direction, you can take a 45 degrees angle. So 45 degrees with respect to x-axis. Or if you can take this as north or this is east. So I am here in the direction of northeast direction. So either the angle theta or with the help of these directions we can represent. So here this vector which is known as position vector. So that is one of the vector. So the second vector, another type of category which is known as displacement vector. Yeah, displacement. How you define displacement? The change in position. Suppose this is coordinate axis. So in this coordinate axis initially I am at here at P. So my position initially at P. After a certain time, I moved from P to Q. So I moved from a position Q. So that position with respect to origin, that is at here. So this is also a position vector. At a time t, so this is also position vector after certain time t dash. So what is my displacement? So displacement will be defined as the shortest distance between initial to final position. Suppose if I draw a vector from here to there, so this is my shortest distance which I walk. Now this is, we can represent as displacement vector. So position is a vector and displacement is also a vector. So the length of the vector represents the magnitude of the displacement and the direction, in which direction I moved with respect to this coordinate axis, with respect to x and y, or with respect to as directions towards to north, east to north. So like that. So here two vectors we learned. One is position vector, another one is displacement vector. Now apart of these two, just recall, if two vectors lengths are same, suppose this is a vector, if I draw a vector, if one is a vector and another one, so these two vectors, if this is a bar and b bar, so these two vectors magnitudes are same and directions are also same. So in this case, these two vectors are known as equal vectors. So these two vectors are known as equal vectors. The vectors whose magnitude and direction is same. So then those vectors are known as equal vectors. And suppose if you are having a vector, this is, let me take a bar, and if you draw a vector which is exactly opposite in the same magnitude and opposite in direction. Now if you can take this is a bar and the down one we have to represent that minus a bar. So this is we can call as negative vector. A vector magnitude is same but direction is opposite. So here I can write that b bar equal to minus a bar. Yeah, b bar is also a vector, but that is exactly equal to negative of a bar. Yeah, negative represents in vectors only the direction of the vectors. And sometimes we need to calculate only magnitude. So here we can represent another vector which is known as modulus vector. Modulus, we know that modulus, it means we represent in mathematics. Suppose what is the modulus of minus 4 value? So modulus removes the negative sign, its value becomes 4 itself. So the modulus of a vector means the length or the magnitude of the vector. So modulus of vector means only length or magnitude. So here we do not represent that in the direction. So modulus vector a bar, modulus vector a bar, we can represent that with the modulus symbol, modulus of a bar, which equal to a itself. So here we don't put direction after taking modulus, because modulus changes the direction of vector if it is negative vector. So modulus vector do not have direction, so it is having only magnitude or the length it is having. It do not have any direction. So this modulus vector is very important to define, very important vector which I am going to talk right now, which is known as unit vector. So unit vector is defined as a vector whose magnitude is 1. A unit vector is a vector of unit magnitude drawn in the direction of a given vector. So that we define as unit vector. Its definition: a vector whose magnitude a vector of unit magnitude. A vector of unit magnitude drawn in the direction of a given vector. Drawn in the direction of a given vector. So what it means? How we can draw the unit vector? Unit means 1. So very important point, you remember that unit means, in mathematics we can consider that as 1. So a vector of unit magnitude drawn in the direction of a given vector. Suppose if I have a vector, so this is very big vector, take a long vector. So this is vector. So this vector name is A bar. To this vector, I want to draw a unit vector. How can I draw a unit vector? So the unit vector can be drawn to a given vector direction, but its magnitude is equal to 1. That can be understood. Suppose this length of the vector equal to, suppose its length of vector equal to 10 centimeter. So 10 centimeter is magnitude. Now to draw a unit vector, I need to draw only 1 centimeter vector. Now this magnitude is equal to 1 centimeter. Now I can say this 1 centimeter is unit vector of given vector. So this is unit vector of A bar. So this is unit vector. Unit vector of A bar. So this unit vector having representation. We will represent unit vector with the A cap. Unit vector equal to unit vector representing with A cap or A hat. How we can represent a unit vector? So we have to take a vector upon its magnitude. Okay, now come to this example at here. So the example A bar, I have taken 10 centimeter. 10 centimeter, you can take this direction also, vector direction towards to east. Upon, what is the modulus of the vector? So here modulus means we can get only the magnitude, only we can get it. So A bar modulus, so I can get only magnitude. So I have to write in the denominator 10. So 10 gets cancelled. I need to get the answer A cap equal to unit vector A cap equal to how much it is? 1 centimeter towards to east. So this is a vector what I drawn right at here. So that is the unit vector. But the unit vector formula, every time you can use A cap. A cap equal to A bar upon modulus A. So unit vector is we oftenly use because sometimes the vector magnitude is given so much. So that much long vector representation is difficult. Suppose if we take one more example. So given that a velocity of the 5000 kilometer 5000 km per velocity towards east direction. So to represent that much long, it's very difficult. We need to represent that 5000 as long magnitude of the vector. So this much 5000 km towards to east is represents very long. Suppose this you can take velocity as a vector. Now instead of representing this much long, it's easy to represent the unit vector. So unit vector means I have to draw only 1 kilometer per hour. So this much small becomes 1 kilometer per hour this is the unit vector of V. So this is unit vector of V bar. So how we can write unit vector? So unit vector V cap equal to a vector by its modulus. So here vector is given 5000 kilometer per hour towards each direction upon magnitude modulus of vector. So I need to get only 5000. So 5000 gets cancelled. What end I can get? I can get that 1 kilometer per hour towards each direction. So a vector which is drawn with a unit, that's what I said, unit means in physics you represent that as 1. So this is helpful to represent vectors in small length. Unit means 1. So for every vector we will represent that unit vector. Yeah, from this knowledge any vector can represent as any vector. Therefore unit vector formula, therefore unit vector A cap equal to A bar upon modulus A. So from this we can write a vector. So in this one this is given vector and this is modulus vector. So I can write that given vector A bar equal to modulus A upon A cap. In this one modulus represents the magnitude and A cap represents direction. Now a vector can represent in two factors. One is its magnitude in terms of modulus vector and another one is its direction in terms of unit vector. So unit vectors are the direction representative vector in the correspondings. So wherever unit vector is given, so that unit vector tells about the direction of the vectors. So try to get to this point. So here I can say, suppose if you are having a two-dimensional coordinate axis, that I will talk in the next time. Right now everything will be bulky. Now apart of that, we have seen that like vectors are both in the same direction, same magnitude and same directions, then those vectors are known as like vectors. So these vectors are represented in the same magnitude and the same direction. So these vectors are also belongs to same plane. So then we can say these two vectors are known as like vectors. So these two vectors are known as like vectors because they both are representing in the same directions. Suppose if we can take vectors which are the opposites. Suppose this is one of the vector and this is another vector. Now they both are representing in the opposite direction and then we can say these two vectors are known as unlike vectors. So these are the different varieties of vectors. So we can discuss when it comes real situation. So all of a sudden if I explain, so you will get irritated and you will lose interest. Now very important one which I am going to discuss at here, so that is known as zero vector. Yeah, in vectors 0 is also a vector. Why it is zero vector? Suppose take a situation, I am having a vector so which is represented in this direction and I am having another vector which is also represented in the same direction. Suppose if I take its value is a bar and its value is b bar. What is the value of a bar minus b bar? Right now, if you can do this vector addition, what the value can get? We will get that as 0. Yeah, if a bar minus b bar, in this case we are getting 0, then we can represent with this as a 0 bar. So 0 bar is also a vector. Yeah, this is also a vector. So is a 0 vector or it's having another name? So this name I can encourage you to remember, this called null vector. A vector which is having 0 magnitude and any arbitrary direction. A vector which is having 0 magnitude and any arbitrary direction, is known as 0 vector. Yeah, not only that, if you can face one more situation. Since a bar is a vector, and right now we learned about 0 bar is also a vector. So if we can add a vector to a 0 vector, what we can get? We can get the same vector. So these are the properties of 0 vectors. Or if we can multiply a number with a 0 vector, 0 times, suppose you can multiply with a scalar 100, what the result we can get? We can get the 0 bar. So 0 bar magnitude do not be changes. So what is the importance of this 0 bar? The position vector of a particle which is lying at origin. So to represent, suppose this is an x and y coordinate axis. So this is x and this is y. Suppose a particle which is located at here, origin. At O, particle is at O. So how do we represent that particle at there? Yeah, particle location is there, particle direction is there. To represent the position vector of a particle lying at the origin, so we can use that as 0 vectors. And one more example, if you can take, the acceleration of an object moving with uniform velocity is 0 vector. Yeah, we learned that acceleration equal to rate of change of velocity. So acceleration A equal to rate of change of velocity, dv by dt. Suppose if velocity equal to constant, so velocity is a vector. If the velocity is equal to constant, what is the constant differentiation? Constant differentiation in this case goes to 0. So 0 is a vector. So here acceleration. So acceleration also here represented with the 0 vector. Yeah, since velocity is a vector, but that velocity is a constant, so differentiation of constant value goes to 0, but here that 0 is represented with the acceleration. So in some situations we need to depend upon 0 vector, especially there are two situations: to represent a particle in the origin and to represent the acceleration of a moving object, constant velocity moving object. So these are the different types of vectors we will encounter in the coming. So here very important, I will encourage you to remember about unit vector. So unit vector is a vector whose magnitude is 1 in that given vector direction. So we can represent unit vector A cap equal to A bar upon modulus A. So in next class we will learn some vector additions other than the head and tail method. By using laws, we are having 2-3 laws to add the vectors. So that concept we will see next class.